Hello viewers, I am Ekta. The topic of today's discussion is DBMS, that is Database Management System Software. We have already been introduced to this term in this series. We have also learned that DBMS acts as a layer between the user and the database. Let us now understand what is DBMS in more detail. The objectives of this discussion are to explain functions of DBMS, to discuss advantages and disadvantages of DBMS. The responsibilities of DBMS are to allow users to set up their data, to process all data requests, to allow concurrent access to database, to provide recovery facilities. For example, in case any failure occurs, DBMS must be able to recover the database to a consistent state. Let us now discuss the 5 major functions of DBMS. The first is to support data access. Second is to support data independence. Third is to support data control or data protection. Fourth is to reduce data redundancy. And fifth is to provide support of a data model. Now let us discuss each of these functions in detail. Function 1, that is data access and data sharing. The steps involved in data access are: the application program determines which data is needed and it communicates data requirements to the DBMS. The DBMS checks to see if the required data is in the database and that whether this program is allowed to retrieve it or not. The DBMS tells operating system to find and retrieve data at a specific location of the disk and how to access the files. The retrieved data is passed back to the DBMS where it is converted into the form required by the application program. Thus, we can summarize the major steps of data access as: the data request travels from application program to DBMS. DBMS makes some kind of checks on the data request and sends it to the operating system. The operating system, after retrieving the required data, sends it back to the DBMS, and the DBMS, after converting the data into the required format, sends it back to the application program. Thus, DBMS acts as a layer between the user and the database. For data access, DBMS supports at least 2 types of languages, that is data description language, abbreviated as DDL, and data manipulation language, abbreviated as DML. DDL is used for defining database objects, whereas DML is used to manipulate or process these objects. Data sharing. The DBMS in a multi-user environment must provide shared access to the data. This implies that DBMS must be able to support shared access to the data. It should also support concurrency, which implies that the data can be accessed by many users at the same time. But for this, DBMS must be able to overcome the problems related with concurrency. One such concurrency related problem is explained here. Let there be ₹100 in a customer's balance, and let there be two teller machines A and B. And let us suppose that both of them read ₹100 simultaneously as customer's balance. Let A tries to add ₹50 to his account, whereas B tries to subtract ₹5 from his account. Now, if A happens to save the results later than B, then the output will be 150. Whereas if B happens to save the result later than A, then the result will be 95. But the desired result is ₹145. Thus, what teller A and B are doing is they are overwriting each other's result, which is not desired. Such concurrency problem should be solved by DBMS by ensuring that either one user should be capable of writing the shared data. Let us now discuss function 2 of DBMS, that is to support data independence. Let us understand what is data independence. Data independence means that applications do not change with change in storage and access technique. That is, applications are independent of storage and access strategy. This also means that application programs can be developed independent of the underlying file structure. This means whatever is the file structure, the application program should be totally independent of that, and that the access methods are independent of programs, which implies that whatever way we are accessing the data at the internal level should be totally independent of whatever way we make the application programs. The data independence is of two types. One is logical data independence. By logical data independence, we mean that the conceptual schema can be changed without affecting the existing external schemas. This change would be absorbed by the external conceptual mapping. For example, let us consider that there is a user in public relations department and the database contains employee details. This user in public relations department will be concerned with only the employee name and employee address, whereas a user in payroll department will be concerned with employee name, employee ID number, employee address and employee salary. The conceptual schema corresponding to these two external schemas will contain employee name, employee ID number, employee department, employee address, employee salary and his skill. Now, let us consider some change is made in the conceptual schema. For example, some new field is added into the conceptual schema. Then this change should be absorbed by the conceptual external mapping and should not be reflected in the external schemas of different users. Sometimes achieving logical data independence is not possible. For example, some field like employee name, which is being used in different external schemas, is deleted from conceptual schema. Then in such case, the change would definitely be reflected back to the respective external schemas, and this change would not be absorbed by the conceptual external mapping and logical data independence would not be achieved. Thus, DBMS should try maximum to achieve logical data independence. The other type of data independence is physical data independence, which implies that physical storage structures or devices used for storing the data could be changed without requiring a change in the conceptual view or any of the external views. For example, let us consider that the employee address at internal level is stored in binary form, whereas at external level this address is seen as a string. Now consider, due to some performance reasons, DBA decides to change its storage structure to decimal. The idea is that even if it is now stored as a decimal, the employee address should still be seen as a string at the external level. This change should be absorbed by the conceptual internal mapping. Let us now discuss what differences in internal level representation should be absorbed by the conceptual internal mapping to achieve physical data independence. The differences can be in representation of numeric data. They can be in representation of character data. They can be in representation of units for numeric data. They can be in the structure of stored records, and the differences can be in the structure of stored files also. All such type of differences should be absorbed by the internal conceptual mapping so as to achieve physical data independence. The third function of DBMS is to support data control and protection. For data control and protection, the DBMS must prevent unauthorized persons from connecting to the database. The DBMS must also provide data privacy. Other than this, the authorized persons should have access only to the data for which they have privileges. The DBMS protects the database by ensuring that all operations to a database system either execute successfully or not at all. Such operations are known as atomic transactions. The atomic transactions always ensure that the database is left in a consistent state after performing a set of operations. The function 4 of DBMS is to reduce data redundancy. Since a data item would be stored only once and will be accessed by many application programs via the DBMS, therefore it is always ensured that there will be a reduction of data redundancy in a DBMS oriented system. The DBMS do not eliminate all data redundancies. There will sometimes be a trade-off between the complete elimination of data redundancies and database performance, which implies that either there will be some data redundancy or there will be a better database performance. Function 5 of DBMS is to support a data model. A data model is a method of representing data and relationships between data. Many data models like entity relationship model, which we have already discussed in this series, exist, but not all data models are supported by real database management systems. But it is sure that a DBMS will always support one or other kind of data model. Let us now move on to the second objective of this discussion, that is to learn the advantages of DBMS. The advantages of DBMS are reduction of redundancies. That is, the centralized control of data by DBMS avoids unnecessary duplication of data and effectively reduces the total amount of data storage required. This is a very important point which is supported only by the DBMS. Not only the reduction of data redundancy ensures consistency in the database, it also ensures the proper utilization of data storage. The second advantage is shared data. A DBMS allows the sharing of data under its control by any number of application programs or users. As we have already discussed, concurrency is an important thing which can be achieved by virtue of DBMS. Integrity. Due to centralized control, data contained in the database is both accurate and consistent. Security. DBMS ensures that confidential data is not accessed by unauthorized persons. And the last advantage is data independence. We have already discussed this advantage of DBMS. We know that DBMS can provide both logical and physical data independence, which means a change made at the lower level of DBMS architecture will be absorbed by the various mapping mechanisms and will ensure that changes do not have to be made at the higher level of the architecture. The disadvantages of DBMS are: cost is a disadvantage of DBMS. Thus, we can say that DBMS is a costly affair. In addition to the cost of purchasing or developing the software, the hardware has to be upgraded for DBMS and application program compatibility. This is probably the only known disadvantage of DBMS. Thus, we have discussed the different steps involved in data access, the 5 major functions of DBMS, that is, to support data access, to support data independence, to support data control and data protection, to reduce data redundancy, and to provide support of a data model. We have also learned the various advantages and disadvantages of DBMS. That's all for today.